So let's take a look at an example where we're actually going to be graphing one of these using transformations. We're going to take a look at y equals 5 times the sine of 1/2 x. Relating this to what we saw in our previous video, this is y is equal to a times the sine of omega x. So first thing that we're going to do is identify our mother function. There are only two of them in this section, and in this case I'd be talking about y is equal to the sine of x. There have been both an amplitude modulation as well as a frequency modulation done to this sine function. So with that in mind, let's discuss both. For the amplitude modulation, I see a coefficient of 5. As such, we are going to multiply all of our y values by 5. That also lets us know that the resulting amplitude is going to be equal to the absolute value of a, which in this case would be the absolute value of 5. Because 5 is already positive, the absolute value is not going to have an impact on it, and the amplitude is simply going to be equal to 5. Now, as far as frequency modulation is concerned, one period is going to go from, the angle goes from 0 to 2 pi. The angle, in this case, is everything inside the parentheses here. So this would count as 1/2 x. Whatever algebra you do to solve for x here, that will be your frequency modulation. In order to solve this for x, I am going to multiply through by 2. So the frequency modulation is going to be multiply all of your x values by 2. That also lets us know that the period is going to start at 0 and it is going to end at 4 pi. So with that in mind, you can use that to express what one period is equal to. Now, because amplitude modulation and frequency modulation are both considered stretches, the order in which you apply them does not matter. So we'll start with the 5 points typically associated with y equals the sine of x, and those would be 0, pi over 2, pi, 3 pi over 2, and 2 pi. The corresponding y values would be 0, 1, 0, -1, and 0. We get those values from the unit circle, treating x values as our angles. Y will be the corresponding ratio for the sine. Then we'll perform a frequency modulation and multiply all of these x values by 2. So all of these x values will be doubled. That'll be 0, pi, 2 pi, 3 pi, and 4 pi. Those will be the new corresponding x values that we'll actually graph. For the amplitude modulation we set up here is multiply all of the y values by 5. So everything that is 0 will stay as 0. 1 will get multiplied by 5, -1 will get multiplied by 5 as well. Now in terms of actually coming up with a graph, we just gave ourselves enough information to figure out what the first cycle looks like, and then we'll talk about how to extend that to a second cycle. So what we're going to do is just mark down the appropriate scale to use. Most of this section when it comes to these graphs is just drawing the exact same graph over and over and just changing your scales. We'll go up to 5, as far down as -5, and plot these x values with these y values. So we'll start at 0, 0, pi 5, 2 pi 0, 3 pi -5, and 4 pi 0. Now when you're connecting these points, I would recommend strongly that you start with a maximum or a minimum and connect it down to the midline to try to create a graph that is as smooth and continuous as possible. Now as a reminder though, we were told to graph a total of 2 cycles, or 2 periods, or 2 wavelengths. Once you have your first period down, recopy this period as though the ending point is the new starting point for the next period. So we'll need 4 more x values. Oh, more x. There we go. And we can follow the pattern that we just got. So this was 1 pi, 2 pi, 3 pi, 4 pi. So the next one would be 5 pi, 6 pi, 7 pi, and 8 pi. Just follow the pattern that you see in front of you. Now, we started at the midline, then we went up to a maximum, then down to the midline, then down to a minimum, then back to the midline. Again, these things are very, very pattern driven. Now, if we wanted to draw a third period, we could extend beyond 8 pi, or if you wanted to, you could also extend into the negative direction. It does continue in both directions, so we'll throw a little arrow so that we know that the pattern repeats. Additionally, as a bonus on this problem, I'd like to identify the domain and range associated with it. Now, this will repeat indefinitely and just keep on going forever. However, if we go this way in my basement, there is eventually a concrete wall, so I guess it can't go on forever, but mathematically, theoretically, it goes on forever. As far as the range is concerned, this goes all the way down to -5 and all the way up to +5. In interval notation, that would be from -5 to +5.